All right, so now I'm continuing the naming of the disaccharide, and I just want to use this one as a reference. I want you to study this structure alone. If you're able to determine this structure as a glucose in a cyclic form, which is glucopyranose, then obviously you'll be able to identify the different monosaccharides that come together and give the correct IUPAC naming for the various disaccharides. Now, this is the structure for glucose. For this particular carbon, when it's an numeric carbon, we don't care whether the O is at the top or at the down because it doesn't actually determine the type of sugar. It just determines the numeric configuration. This side too, we don't actually care about it whether it's at the top or at the down. It just determines whether it is L or D sugar. Apart from that, the positions of this OH determine the type of sugar that we are dealing with. So this is glucopyranose, which is more like glucose in the cyclic form or the cyclic structure of glucose. Now, if you take this sugar, this is how we are going to name the disaccharides. First, you have to identify whether this one is alpha or beta. And because the position of the disaccharide or the position of these glycosidic bonds, see, we are seeing something like this. So that the OH was at the top here. And with the OH at the top, we are calling this one beta, right? If you look at this side too, the O is at the down, so we are calling this one alpha. So now we are done with half of the work. We are not done with half of the work, but we are getting closer to half of the work. And you consider whether it's a D or L sugar. If you're having the CH2OH, CH2OH all at the top, then this one is a D sugar. This one is also a D sugar. Now it's up to you to identify whether this one is glucose, mannose, galactose, or allose. Now, looking at the structure, I'm making this one as a reference so that you can identify which sugar is this or which monomeric sugar you are considering here, as well as this one. So if you take this sugar, this one is glucose. OH, we are not caring about the first one, only the second, third, and fourth. So the OH is here, you are having the OH down, same thing here, also here, also here. So this one is glucose, but it's in the cyclic form and it's the beginning of the sugar. So we are calling this one beta D glucopyranosyl. Pyranosyl because that is not the end of the naming of the sugar. There's another sugar also. So I mean, shortening it as pyranosyl. Then we bring something like this. Then we indicate the type of glycosidic bond that is here. And here, like what you are seeing, is between carbon 1 and carbon 4. So 1 is to 4. That's the name of the glycosidic bond or the linkage that is connecting these two monosaccharide units together. Then we come to this side. This side, is it mannose? Is it galactose? So you have to use this one as a reference as well if you don't know the difference. So this one is OH here, we are having OH here, we are having OH. So this one is also glucose. So, but this one is of alpha form. So alpha, then D glucopyra. So when it comes to this side, because this is the large sugar, pyranose, then that will be the IUPAC name for this particular disaccharide, of which you are referring to as maltose. The trivial name for this particular disaccharide is called maltose. When you have glucose and glucose coming together, it's maltose. Just that this is the IUPAC name. Now, when you come to this side, consider this one. If you are using this one as a reference, you are still going to see something like OH, but this time the OH is at the top instead of being at the down. So now we are having one difference in the configuration as one carbon. At this side, it's still the same. This side is still the same. So this one, and you are having an epima, which is more like glucose, but having a different in configuration as carbon 2, then you are referring to this one as mannose, right? If you come to this side, so this one looks like glucose because the OH is here. But on the third carbon, we are having the OH also at the down, at the top. Then on the fourth carbon, instead of we having the OH at the down for us to consider it as glucose, this time we are having the OH at the top. So this time around, this one becomes galactose because it's having a change in configuration as only carbon 4. And this one is an L sugar, like what I've indicated here. This one is a beta sugar. This one is also a beta sugar because of the position of the OH. So beta. Now this is how we are going to name it. Like what we did here. We are just going to name it as beta D. This one is mannose, right? So pyranosyl. Why is it pyranosyl? Pyranosyl because it's a 6-member ring. And we are using the syl because that's not the end of the sugar. We are having another sugar. So then we indicate the type of glycosidic bond. This one is what? Beta, right? So 1 is to 4. Syl 1 is to 4. Then we come to the naming of this particular sugar. This one is galactose. So let me bring it here. This one is beta, so beta, then L, then we start naming the whole sugar itself. Galacto. Assuming you're having another sugar again, then we have named it galactopyranose. So then we move to the other glycosidic linkage, name it, and also add the other sugar. But this one is the last sugar, so galactopyranose. So that's the IOPAC name. And you're having mannose and you're having galactose. That one is also having a trivial name. But if you're having galactose and glucose coming together with your glycosidic bond, they are referring to that one as lactose. So lactose, sucrose, maltose, they are all forms of what disaccharide. They are all having their IOPAC name, just that these are trivial names. So when they ask you to name this, and even if you know that this one is a combination of glucose and glucose, you can't just write maltose because they are having about 7 marks or so attached to it, and you are just writing maltose. You are not going to get a mark. They are even going to mark you wrong. They expect the IOPAC name. So with this, determine the configuration, the numeric configuration, and also whether L or D, and also determine whether it's glucopyranose or mannopyranose. They all have a lot of marks, indicating the right name for the glycosidic bond. They all contain a lot of marks. So don't joke with the naming of the disaccharide. At least you have the idea about how they name the disaccharide. So I've posted some of the questions inside. Try and solve it and let me have your answers by the close of the day.